Welcome. Today, we're diving into key concepts in statistics, from hypothesis testing to regression and data visualization. This unit is part of our Data Analytics Handbook, designed to build your skills in analyzing and presenting data clearly. Let's explore how these tools help us make smarter decisions with numbers. Statistics helps us make sense of data in two key ways. First, descriptive statistics. This is about summarizing what we have. We look at averages, medians, how spread out the data is, and use charts to visualize it. It answers the question, what does this data look like? Then, inferential statistics goes beyond the data we collected. It uses tests, confidence intervals, and models to help us draw conclusions, to say what we can reasonably infer about a bigger picture. Here, we have a simple set of numbers, 6 values that will help us explore some basic descriptive statistics. We calculate the mean, which is the average, the median, or the middle value, and the standard deviation, which tells us how spread out the numbers are. The summary gives us a quick snapshot, the minimum and maximum, plus the quartiles that divide the data into 4 parts. These stats give us a clear picture of the data's shape and spread. Here, we're looking at the correlation between sepal length and petal length in the iris dataset. The value is about 0.87, pretty close to 1. That tells us there's a strong positive relationship between these two measurements. When one gets bigger, the other tends to get bigger too. This slide introduces the idea of correlation, a key concept in understanding how variables move together in statistical analysis. Let's talk about 2 key ways we summarize and standardize data, quartiles and z-scores. Quartiles split our data into 4 equal parts, helping us understand its spread. Z-scores, on the other hand, tell us how far a value is from the mean, measured in standard deviations. We calculate a z-score by subtracting the mean from the value, then dividing by the standard deviation. Both tools help us make sense of data, especially when comparing different sets or spotting outliers. Let's talk about how we decide if an effect is real or just noise. We start with the null hypothesis, the idea that there's no effect at all. Then, we run a test and get a p-value, which tells us how surprising the data is if the null were true. If that p-value is small, usually less than 0.05, we reject the null. That's the basic decision rule behind hypothesis testing. Now let's look at the t-test, a fundamental tool for comparing 2 group means. Here, we see the test statistic, t, which is 2.41 with 38 degrees of freedom. The p-value is 0.021, which is less than 0.05. That tells us the difference between the groups is statistically significant. In other words, the means really do differ. This test helps us decide if what we're seeing is likely due to chance, or if there's a meaningful effect at play. Now let's look at how we test relationships between categories using contingency tables. Here, we create a table crossing gender with pass rates. Then, we apply the chi-squared test to see if these 2 variables are related, or if any observed differences could just be due to chance. This method is a cornerstone in statistical analysis, helping us understand connections in categorical data. It's simple, but powerful. Here, we're looking at a simple linear regression model. It predicts miles per gallon based on the weight of a car. The key number is the slope. It tells us how much MPG changes for each unit increase in weight. This kind of analysis helps us understand relationships between variables, and it's a foundation for more complex statistical modeling. It's a powerful tool for making data-driven decisions. Here, we're looking at a logistic regression model. It predicts a yes or no outcome, in this case, whether a student is admitted or not. We use 2 predictors, GRE scores and GPA. The model estimates the relationship between these variables and admission chances. This approach is powerful for binary outcomes, helping us understand how each factor influences the odds of being admitted. It's a key tool in statistical analysis and visualization. When it comes to data visualization, we have a powerful set of tools at our fingertips. Starting with simple scatter and line plots, we can explore relationships in our data. Next, histograms help us see the shape of a distribution clearly. Box plots go a step further, showing spread, medians, and outliers by group. And for elegant, customizable graphics, ggplot2 stands out as a go-to package. Together, these tools bring our data to life. We've reached the end of this course. Remember, the best way to get better is to keep practicing with real datasets. Use the tools we covered, from basic plots like histograms and box plots to advanced visualizations with ggplot2. Apply hypothesis tests, build models, and always start by describing your data clearly. Keep exploring, and your skills will grow stronger every day. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.